Hello out there, welcome to this tutorial on approximation and errors. In this video, we'll be looking at error and range of values of measurements, where we'll be looking at some approximated values, get the possible error, and then the range of values of such measurements. So we start with the first problem. Problem 1. What is the range of values of the length of a stick 8 centimeters to the nearest centimeters? So in our solution, we look at the measurement. The measurement here is 8 centimeters. The error is going to be based on the approximation that the measurement is given. So the measurement is given to the nearest centimeters. So we look at the smallest centimeters, whole number here in this case, since it is to the nearest centimeters. So we look at it as 1. That 1 now is going to be divided by 2, which will give us 0.5. So the error is going to be plus or minus 0.5 centimeters. Okay, now we look at the range of values now. The range of values is going to be 8 centimeters plus or minus 0.5 centimeters. So that we now get our range of values to be 7.5 centimeters and 8.5 centimeters. We got this 7.5 centimeters from 8 centimeters minus 0.5 centimeters. That gives 7.5 centimeters. And the second value is 8 centimeters plus 0.5 centimeters, which gives 8.5 centimeters. And that's the range of values of the measurement from the approximation of a stick 8 centimeters to the nearest centimeters. We then go to problem 2. For problem 2, state the range of values of the height of a man 1.65 meters to the nearest centimeters. In our solution, we look at the measurement. The measurement is 1.65 meters and we were told to the nearest centimeters. So we are going to convert this 1.65 meters to centimeters by multiplying by 100, and that will give us 165 centimeters. We go ahead to get the error. This error here is similar to the previous problem, that is the immediate problem. The nearest centimeter is still going to be the same error. So we have the smallest unit there to be 1 centimeters, and we divide the 1 centimeters by 2, it gives 0.5 centimeters, which is going to be plus or minus. So we get our range of values now, which is going to be 165 centimeters plus or minus 0.5 centimeters. 165 minus 0.5 gives 164.5 centimeters, and 165 plus 0.5 gives 165.5 centimeters. Since the problem is given to us in meters, we convert this back to meters by dividing by 100. So that will give us 1.645 meters and 1.655 meters. And that gives the range of values of the height of the man, 1.65 meters to the nearest centimeters. That's all for problem 2. We go to problem 3. For problem 3, we're to find the range of values of the population of Nigeria, 210 million to the nearest million. So we start with the solution, get our measurement. The approximated measurement is 210 million, and to the nearest million, the smallest million is 1 million. So we get our error from there. That is 1 million divided by 2. So the error is plus or minus 0.5 million. So that the range of values of measurement now will be 210 million plus or minus 0.5 million, and 210 minus 0.5 gives 209.5 million, and 210 plus 0.5 million will give us 210.5 million, which gives the range of values of the approximated population of Nigeria to the nearest million. So we go to problem 4. For problem 4, what is the range of values of the amount of a phone 30,000 naira to the nearest 1,000 naira? So in our solution, so the approximated amount here, which is going to form our measurement, is going to be 30,000 naira, and it is to the nearest 1,000 naira. So the smallest 1,000 is 1,000. We now divide it by 2. That's going to give us 500 naira, and our error is going to be plus or minus 500 naira. Then our range of values now is going to be 30,000 plus or minus 500 naira, so that our first value is going to be 29,500, and the second value is 30,500 naira. Remember, 30,000 minus 500 gives the first value, 30,000 plus 500 naira gives the second value, which gives the range of values of the amount of the phone. So that's the end of solution to problem 4. We then go to problem 5. For problem 5, the distance between two cities is given as 250 kilometers to two significant figures. What is the range of values of the distance? So in our solution, our measurement here is going to be the approximated distance, which is 250 kilometers. And then our error is going to be taken from the approximation. Two significant figures is equivalent to the nearest 10. Why are we picking the nearest 10? The unit digit is 0, so the 10th digit is given, so which means it is to the nearest 10. If both the unit digit and the 10th digit are zeros, then it is going to be to the nearest 100, and so on. So anything given to you as significant figures, you have to go this way to get the actual approximation in terms of nearest 10, nearest 100, nearest whole number. If it is given to us now as nearest whole number, the error is going to be the smallest whole number, which is 1, then divide by 2. We add and then subtract to give us the range of values. So that's that for that. So our error here is going to be plus or minus 5 kilometers, since it is to the nearest 10, and 10 divided by 2 gives 5. So our range of values of the distance now is going to be 250 kilometers plus or minus 5 kilometers, and that will give us 245 kilometers and 255 kilometers. 250 minus 5 gives this, 250 plus 5 gives this. And that's all for the solution of problem 5. We then go to problem 6. For problem 6, calculate the range of values of the length of a metallic rod given as 1.2 meters to the nearest 0.1 meters. So since the approximation is to the nearest 0.1 meters, our error is going to be this 0.1 divided by 2. So in our solution, we are going to have our measurement to be 1.2 meters, and our error, we have said it that it is going to be 0.1 meters divided by 2, which is going to give us 0.05 meters to be added and then subtracted from the measurement to give us our range of values. That's going to be 1.2 plus or minus 0.05, and 1.2 minus 0.05 gives 1.15, and 1.2 plus 0.05 will give us 1.25 meters. So that's all for problem 6, and this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.